So now, last time we talked about that there are two types of actually progression. We have what you call arithmetic progression, and we also have the geometrical progression. So we looked much about the arithmetic progression, where we talked about having the actually a number pattern upon adding the constant number. So now we'd like to go for geometrical progression, where we do have the number pattern upon multiplying the constant number. Let's consider actually in this case. Let's say we have a number pattern which is given as 2. Let's say 4, and the 16 should be 8, 16, 32, and let's say we have 64. And they assume that the values can keep on going in this case. So now, this kind of the actually a series, it is said to be the geometric progression. It is no longer arithmetic because there is no constant number which is being added to have the next number. What is happening is that we are multiplying the constant number in order to have the next number. For this case, we have actually a 2 as the first term, which is given as 2. And now, in order to have the next value, what is happening is that we are multiplying 2 actually for each and every term. So now we have 2 times 2, which is 4, and 4 times 2 we have 8, and 8 times 2 we have 16, and 16 times 2 we have 32, and 32 times 2 we have 64. So that is the typical actually geometric progression. And what is that number what is that constant number we are adding with? Should be we are multiplying with. And that constant number is given as the common ratio, symbolized as R. And how do we have the common ratio? We actually have the common ratio upon having, so we do have the common ratio upon having dividing the succeeding value divided by the preceding value. For this case, we have it as 4 divided by 2, which is given as 2. And also on the same case, we can also have 8 divided by 4, which is the same as 2. We can also have it as 16 divided by, let's say, 8, which is given as 2. And also even 30, actually 64 divided by 32, which is given as 2. So that's how the common ratio is actually obtained. So it's something different with arithmetic progression, because in the arithmetic progression, the constant number that we happen to add, it is said to be the common difference. Now for this case, the constant number we happen to actually multiply, it is said to be the common ratio. And for instance, let's say we have this kind of a GPC. Let's say we have 12, and we have -4. And let's say we have 1/3. And assuming that a pattern can keep on going in that way. So what is the first term as well as the common ratio for this case? So now the first term remains the same, which is given as 12. And what is the common ratio? So now the essence behind the common ratio is that the succeeding value divided by the preceding value. In this case, this is the succeeding value, this is the preceding value. So what will happen is that we'll have it as -4 divided by 12, which is the same as, now we have the common denominator, which is common factor, which is given as 4. We have 4, and this is 3. So which means the common ratio is given as the -1/3. Or else we can also have the common ratio being expressed with these two values, where you'll be required to express this mixed fraction as the single fraction, and of which you have it as, it should be 1/3, and divided by should be -4 in that case. And we should have to express this as the single fraction. Now have 3 times 1 plus 1, that is given as 4/3. and our half times 1 over should be 4. That is the same as 4 and 4. That should be negative here. So that is the same as 1 over negative 3. So mind you, having negative a over b, it is the same as a over negative b. So keep that in mind. So how about if we have, let's say, this case. Let's say we have another actually geometric progression series of our interest. Let's say we have 1 over 2, 1 over 3, and let's say we have 2 over 9. Let's say this is the geometric progression series. What is the first term as well as the common ratio? So now the first term is given as 1 over 2, and the common ratio, it is given as 1 over 3, and that divided by 1 over 2, and which is the same as 1 over 3 times 2 over 1, which is the same as 2 over 3. So that's the actually common ratio, and for this actually a series. You should have to know. So now there's something you should have to understand. Now let's go back to the first the first geometric series that we had. Let's say we have 2, 4, 8, let's say 16, and we have 32. Let's say we have also 64. So now you should have to understand that one of the characteristics of the geometric progression series is that the common ratio remains the same at each and every point. The common ratio here is the same as the common ratio here, and also the same as the common ratio here, and also the same as the common ratio there. And even in the same case, this is also the same as the common ratio there. So in this case, what it means is that 4 divided by 2, it is the same as 8 divided by 4, which is the same as 16 divided by 8, which is the same as 32 divided by 16, which is the same as 64 divided by 32. Now if this is the case, let's say we have this kind of a scenario. Let's say we have the geometric progression series given as x plus 2 comma x, let's say plus 3, let's say x plus 4, and assuming that this is actually this is the geometric progression series. What is the value of x and the values of the values of the first 3 terms? Let's say this is the actually geometric progression series. So now in this case, we should have to understand that since this is geometric progression series, this is the first term, a second term, a third term. So now how should you have the value of x in this case? So using the same principle, you should have to understand that the common ratio here, it is the same as the common ratio there. So with that, then we'll have to equate them. We'll have x plus 3 divided by x plus 2, which is the same as, now have x plus 4 divided by x plus 3. In this case we'll have to cross multiply, so which means we'll have it as x plus 3 and times x plus 3, and which is equal to x plus 2 and times x plus 4. Now that is the case. Then what will go next is that we'll have to expand. That will be given as x squared and plus 3x, and also plus 3x and plus 9, which is equal to x squared and plus 4x and plus 2x, and which is plus 8. So in this case we'll have it as, now this one will have to cancel. We'll have 6x plus 9, which is the same as 6x, and that is plus, there should be 8. So what's going on here? It seems that all values will go. Actually, let me take it back. You have x times x, that is x squared, and the 3 times, actually x times 3, we have it as 3x, and this is 3x as well, this is 9, and here we have it as 2x, should be x times x, and happen to lose everything there. But let me just have to change the components. Let me have this kind of the series. Let me have it as, let's say, x plus 1, and let's say we have x plus 3, and let's say have x plus, let's say, 8. Let's say this is the geometric progression series. So what is the value of x and also the values of the first, let's say, 5 times? So in this case the principle remains the same. We'll have x plus 3 divided by x plus 1, which is the same as x plus 8 divided by x plus 3. In this case we'll cross multiply. We'll have x plus 1 times x plus 8, which is the same as we'll have x plus 3 times x plus 3. So now in this case we'll have to expand. We'll have it as x squared and that plus 8x and that plus x, that is plus 8, which is the same as x squared plus 3x and that plus 3x, that which is plus 9, and of course this and this will go. That will be given as, now should be a 9x plus 8, which is the same as 6x and plus 9. So in this case 6x will go to this side, and that will be given as 9x minus 6x, that which is equal to 9 minus 8, because this 8 now have to fall that on. And what goes next? Now in this case we'll have it as, should be 3x, because 9x minus 3 should be 6x, we'll have it as 3x, so which is equal to 1. Now the value of the x will be given as 1 over 3, so it should be that. Now in this case we have the first term, that is the given as a, we'll have it as, should be 1 over 3 and that plus 1. And what is that one? We have it as this. There should be 3 here, 1. This is the same as 4 over 3. That is the first term of the series. Let's say we should have it as the first term. I should have it as the first term. Then we have this as the second term. And what is that one? So have it as the second term. And what will be that? We'll have it as 1 over 3 and plus 3. And what is that? We have 3 and the plus there, we'll have it as 9, and this is the one which is the same as 10 over 3. So that is the actual second term. And what is the third term? We'll have it as 1 over 3 and plus 8 of 1. So in this case, what will be that? So let's also doing the same as well. That is having the common denominator. Of course we'll have the common denominator which is given as 3, of course, and the 1 into 3 will have it as 3, and I'll have it as 24 here, and plus then also have 3, that is the same as 27 over 3. That is the third term. So which means we can be able to interpret this in terms of those values. So which means the first term is given as, should be 4 over 3. Then the other one is given as 10 over 3. Then the other one is given as 27 over 3. So keep that in mind. Then we'll have that one in this way. So which means this is the seed that we have, 4 over 3 and our comma 10 over should be a 3. and a comma 27 over 3. Now, what is the common ratio for this? Now, the common ratio is given as r is equal to 10 over 3, and that should be divided by 4 over 3. So which means we'll have it as the common ratio being given as 10 over 3 and the times 3 over 4. In this case we'll have it in this case, and the 2 to 4 we have it as 2, and this is 5. So which means the common ratio is given as 5 over 2. So keep that in mind. So now that we have the common ratio and that we have the first 3 actual terms, we can be able to have the other actually 2 terms, and since we are aiming at having the first 5 terms, what we are remaining with? We are remaining with 2 more terms. So which means we'll have a 5 over 2 times this, we'll have the 4th term, and 5 over 2 times the 4th term, we'll have the 5th term. So try to have that at your own actual time. You also think about this one as well. Let's say we have x plus, let's say 4, comma x plus, let's say a 9, comma x plus, let's say a 15. Let's say this is the geometric progression series. Now find the first 10 terms if this is the case. So that will be obtained upon having the value of x and going over all the process that we have gone through here. So try to have that one out. So now, what is the nth term of actually geometric progression? Let's say we have this kind of the geometric series given as 2, 4, let's say 8, 16, in this case. Let's say this is the case. How can you be able to have the actually a term on whichever the position for the actually a geometric progression? In other words, how can you be able to have the nth term and which is said to be the last term of the geometric progression series, like the way we discussed about the arithmetic progression nth term? So now, first thing you should have to understand that the nth, actually the first term of the series is given as 2. And we should have to understand about the common ratio. What is the common ratio? We'll have it as 4 over 2. That is the same as 2. So now, how can you be able to have the nth term of actually geometric progression if this is the case? Now the formula for the nth term of the geometric progression, it is given as ar to the power n minus 1, and of which n corresponds to the number of terms, and this is the first term and this is the common ratio. And let's say we have to actually calculate the term on position 60. It means in that case the value of n, it is given as 60. Then I'll have to substitute into actually this formula, then we'll have the term on position 60. So in this case we'll have it as 16th term. That will be equal to, what's the first term? We have it as 2. And what is the common ratio? We have it as 2 as well, to the power 16 minus 1. And that is the same as 2, and times, that is 2 to the power 59. That will be expressed as that. Using the laws of indices, we know that having this 2, it is the same as having 2 to the power 1. So since the bases are the same, we'll have to add the powers. We'll have 2 to the power 1 plus 59. And with a calculator, you'll be able to have what is that. But this is the formula for the nth term, and in the actually geometric progression series in that case. So let's say we have this case. Let's say we have a geometric series given as 128, and let's say a 64, and such that we have 32, and let's say we can keep on having the values. So what is the nth term formula for this case? So now we should have to understand that the nth term formula and that should be expressed and upon having the first term as well as the common ratio, where the number of terms are not known. Like the way we discussed about the geometry, like the way we discussed about the arithmetic progression. In this case, the first term is given as 128, and the common ratio is given as 64 divided by 128, and which is the same as 1 over 2. And we don't know the number of times. Anyway, we are not much actually interested to have the number of terms in that case, but all we want is to have the nth term formula. So what is the nth term for the geometric progression? We have it as nth term is equal to a times should be r to the power n minus 1. So in this case, the first term is given as 128. In the terms, what is the common range? We have it as 1 over 2 and up to the power n minus 1. So keep that in mind. And how can we have it all? And of course, we can be able to simplify further using the laws of indices. And now in this case, we have it as the nth term being given us. We can be able to express 128 to have the base actually 2. That will be given as 2 to the power 7. And on the same case, actually 1 over 2 is the same as 2 to the power negative 1 times to the power n minus 1. You can have that understand. So just have to be flexible with the laws of indices. So we have 2 to the power 7 and the times. Now in this case we'll have it as 2 to the power. Now this negative 1 will multiply n minus 1. So in that case we'll have it as n minus n plus 1. And since the bases are the same, then we can be able to add the power. So have it as 2 to the power 7 and should be plus, and negative n should be plus 1. So in this case, this is the same as 2 to the power 7 minus n, and that should be plus 1. And of course, this is the same as 2 to the power 8 minus n. So this is the nth term formula of our interest in that case. So that is the nth term formula for the geometric progression if we have the first term as well as the common ratio. So now, what is the 15th term? Now we are looking for the 15th term. Now in this case, in order to have the 15th term, we'll just have to substitute actually a value of n which is 15 in the nth term. That will be given as 2 to the power 8 minus 15. So with a calculator we'll be able to have the 15th term in that case. And likewise also try to have the 20th term, let's say to have the 12th term, and also let's say the 16th term. You have it in the same way. And for instance, let's say we have this actually a geometric series. Let's say it should be given as a 10 of 2 divided by 3. And let's say we have 16 and we have 24. Let's say this is the case. Now find the nth term formula, and they should also have the actually a 16th term, and therefore this is actually a geometric progression series. So now, how should you have the nth term? We should have to understand that the first term it is given as 10 of 2 divided by 3, and of which this is the same as should be 3 times 10, 30, and plus 2 we have is 32, should be 32 divided by 3. That is the first term. And I wish to have the common ratio that would be given as 16, and I divide by 16 divided by 32 over 3, and I wish is the same as, or have 16 of 1 times 3 over 32. The which is the same as 1, we have is 2. so which means we have 3 over 2 as the common ratio. And now what will be the nth term formula for that case? So now the nth term formula for actually geometric progression, we'll have it as AR to the power n minus 1. So in this case, the nth term formula will have it as, what is the first term? We have it as 32 over 3. And what is the common ratio? We have it as, it should be 3 over 2 to the power n minus 1. And of which you cannot think of having this one cancel this one, because this one is under the power for that, so you cannot be able to have that out. And also in the same case, you cannot be able to simplify this to have the same base and to have the same as that one. It is impossible. Then just have to leave it in this way. This is the nth term formula and for that case. So now what is actually a 16th term and for the series? How should we have the 16th term of the actual series? So now 16th term, we'll have it as now 3 over 2 should be 32 over 3, and the times we'll have 3 over 2 to the power, actually now we'll have n as 60 minus 1. So you'll be able to subtract here with the calculator. You have what is this to the power that one, then you multiply the answer with that one. So keep that in mind. And let's say we have, in this case, now think about this as well. Let's say we have the geometric series given as 2 should be 12, comma negative 4, let's say, comma 1 over 3. Now find the value of, let's say, 20th term if this is the case. And also in the same case, you should have the value of the 30th term on the same case. And let's say we have another, actually a geometric series that you can also have it about. Now let's say we have it in this case. Let's say we have it as 9, negative 6, 4. Let's say this is the case. What is the value of, let's say, 61st term? What is the value of the 61st term? And also what is the value of, let's say, 71st term? So try to have that out at your own time. And also on the same case, let's say we have this case. Let's say we have the actually geometric progression say given as x minus, let's say, 5, comma x, let's say, minus, let's say, 12. You have x minus, let's say, 21. Let's say this is the typical geometric progression series. What is the value on, let's say, 15? What is the 15th term? And what is, let's say, 20th term? And also what is 32nd term if this is the case. So try to have that at your own time. So now there's something you have to understand as well. We know that we know that the nth term formula of a GB is given as AR to the power n minus 1. Let's say we have an interest to have the first term. What is the formula for the first term? In this case, it means the n is equal to 1. We have AR 1 minus 1, which is the same as just have it as A. So this is the formula for the first term, and which corresponds to the value, which corresponds to the actually, which corresponds to the symbol of the first term as well. And let's say we have an interest on the actually a second term. So in this case, we have it as AR 2 minus 1, which is the same as AR. So this is the formula for the second term in this case. And let's say we have an interest of the third term, we'll have it as AR 3 minus 1, which is the same as AR to the power 2. this is the formula for the third term. And let's say fourth term, we'll have it as AR4 minus 1, which is the same as AR to the power 3. So this is the formula for the actually fourth term. So now you can see that there is a trend. At each and every point there is an increase of the value of R at each and every point. For this case, we have the first term A, the second term we have R power 1, the third term R power 2, the fourth term we have R power 3. So which means even if you can have, let's say, 20th term, we'll have AR power 19. So the position is decreased by 1. Let's say a 15th term, we'll have AR power 14. So you should know those things. So which means if we're checking about, let's say, a 15th term, we'll have R power 49. Let's say we have this case. Now we have the case whereby we have the question like this. Let's say we have the second term of a GP is 12. Let me just have to give you in a weight form, you should have to get it. So now let's say this is the question. The second term of a GP is 12. So we have to that the second term, that is the way to be much actually careful with, and that is 12. And the fourth term is actually 108. Find the first term, the common range, the nth term formula, and sum of the fourth term as well as the 14th term. So how should you have them all? So now you should be able to understand that as the question itself suggests, we are being given that the second term, what is the second term corresponds to as far as the geometric progression is concerned. So the formula for the second term, now the second term, the formula, now the second term is given as 12 according to the way the question is. And what is the formula for the second term? We have it as AR, that would be equal to 12. So since the first term and the common ratio are known, we have that one as the first term. Should be the first equation. And while the fourth term is actually 108, so which means we have it as the fourth term is equal to 108. And what is the fourth term formula? We'll have it as AR to the power 3. That is the same as 108. So this is the given as equation 2. The next we should have to solve for the common ratio as well as the actually the first term, and for those the actual two equations. So what will go next? So now what will happen is that we'll have it as this. We'll solve for actually two equations simultaneously, either using the substitution method, or we can use the actually a ratio formula. And what is the ratio formula? So in that case, we can be able to have the ratio of the second actual equation to the first equation. That way, we'll have it as AR to the power 3 is equal to 108, and then divided by AR is equal to 12. So now for this case, it means we'll have it as this. So that's the simple way you can go for. Of course, this is the same as the substitution method as well. I understand you know how to solve the actually equations simultaneously using the substitution method. So that is, so which means the first term and the first term will cancel. In this case, we also have it as R to the power 2 is equal to, and what is actually 108 divided by 12? 108 divided by 12, and what is that? We have it as 9, so which means we'll have it as 9. Then we'll have the square of the both sides, that will be given as the plus or minus. You should know that. Then R is given as, now should be -3, and also R is given as the +3. So now those are the actually values of the common ratio you have to understand. And at the next you have to go for the common difference. So for this case you may just have to choose the single value of r that will be used throughout the actual question. Let's think of using the positive value of r, which is given as 3. Now in order to have the first the first term, you may think of substituting the common ratio into either equations. Let's say we should use the other equation. So which means we'll have AR is equal to actually 12. And we have the common ratio as 3, we have it as 3A, which is equal to 12. So what is the actually first term? We'll have it as 4. So which means the common ratio is given as 3 and the first term is given as 4. So keep that in mind. And the next we should have to go for the other question. That is a question C. So what is the question C? We actually to come up with the nth term formula. So the nth term formula, it is the formula expressed when the number of terms is unknown. So in this case we have it as AR to the power n minus 1. So we know the first formula, the first term, which is given as 4 times, and what is the ratio? We have it as 3 to the power n minus 1. So we cannot be able to simplify this. And of course you may think of having this using the laws of indices. 4 times, now 3 to the power n, and times 3 to the power negative 1, according to the laws of indices. So because having a to the power n minus actually to the power m, n plus m, you know it is the same as a to the power n times a to the power m. Likewise, if m is negative, it means we may have the case where we have a to the power n minus m. So that is the same as that. And that is, if you have much interest on that, you can have that understand. So which means, you know, this is the same as having it as 4 times 3 to the power n and times 1 over 3. You can have that understand. And of course this is the same as 4 over 3 and times 3 to the power n. That can be given as this, if you may have an interest to go for that. But if you think of having it being ending here, it is okay as well. So that is the nth term formula, and therefore after that case. Now that we have the nth term formula, we can be able to have the sum of the 34th term as well as the 14th term. And what is that? Now in this case what we're looking for is we should have to calculate the summation of 34th term plus 14th term. In this case, using the nth term formula, what is actually 34th term and what is actually 14th term? So you'll be able to have that out, as you already know how we can be able to have these values. So on the nth term formula, we just have to substitute where there is n, have 34, and plus where there is 40, actually n have 40, then you have these values, then you actually have to add them. Let me just have to write you. So in this case it means we have it as 4 times, let's say 3. What is the nth term formula? Let me use this because I erased the first one. So have 4, and I should put 4 over 3, and that times 3 to the power, now have 34. That will be the 34th term. And we'll have what is that value plus, and also the 14th term. So that's how you just have to get that an up to in that case. And let's say we have been told that the 16th term of a GB. Let me just give you this question as well in unit form. Now let's consider these two questions. Now given that the third term of a GB is 63, that is the third term being given as 63, and the 10th term is 105. The 10th term is 105. Find the common range, the first term, the nth term formula, and the sum of fourth as well as the 13th term. So that one is like the way we actually had it on the first actual question. So try to tackle it out. Actually, try to tackle it out in that case. So have the third one. So now the third one says that given that the 16th term of a GP surpasses the third term by 5, meaning what? 16th term surpasses the third term by actually a 5. What is the meaning of that one? So the meaning of the way it is surpass, it means exceeding, or should be something about the difference or exceeding. That's the difference between. So which means the difference between the 16th term minus minus the third term is given as should be 5. That is surpassing, or we call it as exceeding. Let's say we have 5 minus 4 is equal to 1. So which means a 5 exceeding 4 by 1, or 5 surpasses 4 by 1. That's the same as that. So which means that actually, which means this one will help us to have the first actual equation. Then we actually to have the 7th term if the 7th term is a 6th one. So which means we should have what is 27th term, and given that the 7th term is a 6th one. So which means this equation and this one will help us to have the first term as well as the common relation. Then you'll be able to have the 27th term. So that's how you should have to understand about actually a geometric progression in some few concepts. So next time we're going to look at the sum of a GP and some other typical applications in real life. Then that will be the way out in this case. So these questions do comes in different actually a mode and orientation. Just have to be much aware about the typical questions that deals with the geometric progression. And if you actually have to practice more, you get used and you want to fail this kind of the questions. And basically during MSc, these questions are very likely to be asked and with huge marks. So don't miss them out. So if you are finding that if it happens that my videos are bringing the happiness into your studies, don't forget to subscribe my YouTube channel, GP Analytical School of Science. Thank you.